we're running behind, so we got to keep moving. Our first speaker tonight is Tyler Scott. He comes to us from the Bay Area. He is a senior UX designer at BlueKai.com. He's a graduate from the Department of Human-Centered Design and Engineering at the University of Washington and is currently, like I said, the senior UX designer at BlueKai. He's an awesome person. He's a wonderful speaker, and I hope you give him your undivided attention. He's got a lot of cool things to say and a lot of good things to impart upon us and teach us tonight. So without further ado, Tyler.
Okay, can you guys hear me? Okay, awesome. So the slides now, so this is great. And the sharks are still down 0 to 2. It seems like 13 minutes left if anyone cares. So, I have feelings, okay? Yes, so I'm trying to modulate my voice because I tend to talk very loud. So if it starts to get too loud, tell me to quiet down, but I'll just revert to my loud talking voice, I guess. What I'm talking about today is big data in the browser. Like I told you before, I work at BlueKai. We're ingesting a ton of user data, whether coming from the internet via tracking tags or offline data like people's CRM databases. So today, these are what's I'm going to cover. I'm going to talk about what exactly is big data, because I think it'll help contextualize what we're talking about, because big data can be a lot of things, right? What potential hazards can big data cause? So this is getting into kind of the nitty-gritty. I'm not going to get too deep in the weeds. I'm going to stay pretty conceptual, but we'll talk about strategies that I found that seem to work to mitigate some of the problems that come with big data. And that's what bullet point number 3 is about. So how many of you know who this is? Show of hands. So as a kid growing up in rural Montana, Jeff Foxworthy was a big deal. And he has this bit, you might be a redneck if, right? So you might be dealing with big data if. So I try to throw a lot of really bad jokes in the presentations. It seems to get you on my side because you feel sorry for me, right? So you might be dealing with big data if, and this is particularly applicable for this town, but if you walk around and you hear people talking about that pig script and you're not working on the follow-up to Babe, Pig in the City. Not funny, right? Here's one. If you hear Hadoop and it's not followed by Gesundheit, you might be dealing with big data. That one's funny. Come on. And then this one is funny just because it's very true, and it kind of hurts to say, but delays for delivery are measured in days rather than milliseconds. You might be dealing with big data. Right? Okay. So let's turn to the almighty Wikipedia. Big data is a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional processing applications. Right? So I much prefer my definitions using Jeff Foxworthy, but this is the accepted definition. And big data has been around for a while, right? It's not like it's a new thing. There's been huge data sets since people were recording ledgers, right? The reason why it's starting to come into vogue now, obviously, like Catherine talked about, there's a lot of money with the buzzword big data, but I think also it's because people are starting to want to take action on their big data. So rather than have it sit in some database that an analyst somewhere is going to be looking at some point in the future, you can have a whole team of people that are hacking away at this thing, finding insights, and then taking action based on those insights, right? That's why we're seeing a lot more big data popping up everywhere. So what exactly is big data? In the context of BlueKai, BlueKai handles 2 billion requests and 100 billion stamp deliveries per day. So by requests, I mean this is someone hitting our servers, requesting our tag, which would then track your browser with data that has been categorized using rules. So when you land on the page, you're going to an auto site, you'll be marked, and this is one thing that I want to make clear with BlueKai, is that we're the most transparent company in this space. We're the industry leaders. We show you everything we know, and it's completely anonymized. But say you're going to an auto site. You'll be marked as being in market for an automobile, right? This happens all over the internet. So when that request comes in for you on the auto site, we see 2 billion of these a day, and it's only growing, right? So that's a huge server log every day. And 100 billion stamp deliveries means for those requests coming in, we are tagging 100 million units of measure stamps categories on people so that you're interested in in-market autos qualifies as one stamp. So it's 100 billion stamp deliveries per day. This produces terabytes of data. It's distributed across hundreds of boxes. These boxes are servers containing all these log files because it's literally impossible to be ingesting this and then also analyzing it. It just has to go to a spot that it gets dumped and then picked up later by Hadoop and Arnetiza and everything else that does the actual analysis. In some of our reports, like that, the last joke of my bad jokes, some of our reports take up to 72 hours to return results. So this is a very, if you're working like the consumer space, this is not acceptable, right? If you go to Google Analytics and you're like, what's going on with my site right now? And it's like, okay, come back 72 hours, we'll have the data for you. Like that just doesn't work in that space. But for the space we're in, it's actually acceptable, and that's actually a short SLA. So I mean, this is what we're talking about with big data. So now that we know what big data is, you have the Wikipedia definition, you have what BlueKai considers big data, we have all this user data coming in. What are some of the hazards, right? So big data takes time, lots of time. And this is two types of time, right? So there's clock time, the wall time, that's the user time. There's also the CPU time, right? So wall time is a function of CPU time and a couple of other things. But all we care about really is the wall time. Even though, say, it takes an hour to generate this report in wall time, it could be 100 hours, 1,000 hours CPU time. So it just takes time, whether it's the wall time or the CPU time. Big data is very costly. So to run all those CPU hours, you got to be either running your own machine, which is consuming power, or you got to buy the machines, right? This is when cloud computing, this is also why big data is partly on the rise, is because now there's access to these huge banks of computers, right? So a lot of you, I'm sure, are familiar with Amazon Web Services. There's a ton of other ones out there. But it costs a lot, right? Especially when you get into these, the super mega large AWS, if you guys are familiar. Yeah, so it gets like really big, really expensive, really fast, right? And after we've got the data, I mean, showing it is a whole other story. So people want to ingest this stuff in the browser now. It's not like Catherine, I think, brought up that it used to be the case that someone would analyze in like email and Excel that was a pivot table of a pivot table to try and have someone get insights from. That sucks, right, from a user's perspective. I want to be able to log into this platform, see a couple insights, take a couple actions, and just get out, right? So browsers themselves are getting better, but just as we all know, when you're trying to do cross-browser dependencies, you can come up with the coolest visualization ever, but if it doesn't work across all the browsers or all the people that you're trying to serve, it fails, right? So they've come a long ways. There's still a long ways to go. So if you distill these down, it's really time, cost, and horsepower. So those are the three major pitfalls that you could be running into working with big data. So with those in mind, I'm going to talk about specific instances in BlueKai where we've hit these and the solutions that we've come up with to handle them. So the two reports I'm going to use, or the use cases, are the audience discovery report and the audience profile report. And I'll talk about what each is and then the problems that we've seen with them and how we've tried to solve them. So audience discovery report, here the UI, it's a couple years old, but it still runs very well. So if you see some dated things, don't throw water bottles at me. It serves our users very well. So what you're seeing here is an audience discovery report, which takes audience definition and then runs that across the entire BlueKai universe. So I was just talking about the 2 billion requests we see per day, the 100 billion stamps. That's one day, right? This is 30 days of data. So imagine how much data we are comparing that with. So in this case, the audience is wealthy female travelers, whatever that definition is. And just real quick, if you're not familiar with like a segment definition in advertising, is taking categories, which are, like I said, in market for autos, which are based off of rules. So like there's a Boolean logic that happens that says, if the page is autos and something else happens, go ahead and attach this attribute to that user profile. So then the user profile gets all these various attributes. We can then come in and say, hey, I'm going to build a profile. So in this case, wealthy female travelers, that could be gender is female. And there's a number of data sources that provide that, so you can OR those together. So it's female, or all these different ways of defining female. You could say the income is, I don't know, 100,000 to 110,000, 110,000, 120,000. You OR all those together. So you build this like definition of what you're looking for in a user profile, right? So then we're comparing that against the entire BlueKai universe to see what correlates highly. The reason for this is if a media planner is needing to increase reach, so they're trying to increase the number of people that their message is reaching, and they want to do it where they're still preserving their conversions, right? So say this has been optimized to be a very converting audience. We want to make sure we preserve those conversions, so we're going to find things that index or correlate highly with what's been defined. So in this case, you can see, I just ran this off 30 days data 2 weeks ago. So spring break planners. So whatever, I don't know what rules are written that define someone as a spring break planner, but they correlate pretty high. A 51 is a good number with wealthy female travelers. So then what we're allowing people to do is then quickly select the things that correlate highly, and then either add to the audience or save a new audience based off of this. So they can run more analytics or target those people. So that's the audience discovery report. It's discovering audiences or categories that will correlate highly with your current audience. The audience profile report is similar. In fact, it uses a data set very similar to the audience discovery report, but it gives you a snapshot of what your audience is. So where this becomes super valuable is for site optimization, right? You're a publisher. You want to better understand who your users are, maybe across the whole site or maybe across a very specific subset. So thinking, again, of conversions. So you tag on the buy now page of your site. You define some rules that say, hey, if someone lands on this page and they click buy it now, like tag them as like high converters, right? So then we can take the high converters audience and then run a profile to see who these people are. And this is across the entire BlueKai universe. So I keep saying that because the universe is huge. And it takes a really long time to do this. So how do we, as a user, they want to be able to do action, like I said, take action on this big data as quick as possible. Immediately it would be best, but it's just not going to happen in some cases. So how can we mitigate that, the problems that you have with the time it takes, with the desire the user wants to achieve something, right? So those are the two reports. So now as I go into the strategies, so thinking back time, cost, horsepower, and we're thinking of the audience discovery report and audience profile report. One problem that we have is that, like I said, the ADR and the APR take up to 72 hours to return data. So that just doesn't work if someone's trying to quickly correct something. Say they started a media campaign. They're spending a lot of money on impressions. They want to be able to optimize as quick as possible, at least to correct if there's like a major error, right? So one way that we can handle this, a possible solution that we've worked with, is sampled data sets. They take significantly less time. So what do I mean by sampled? It's just like with statistical sampling, right? So if you have a huge data set and you want to figure out about what this, say you're trying to read into a certain attribute and you're trying to figure out if this attribute correlates highly or not, like we do with the ADR, you could take a sample that's representative of the whole. The problem is that sample could very well not represent. There could be something in the sample that throws it off. We can work to, and that's why I leave it to the data scientists. Like I barely pass statistics. I'm not the person that'd be answering that question. But we can take a sample data set, and one that's been built by someone who understands this stuff, and be able to return at least results that will have someone be able to take action that won't be incorrect once the sampled set comes back. So for instance, the way that we do this is we use a favorite report. So if you run a query and you say, hey, this is important to me, I need to answer some questions with this, and I need them on the full data set. I know it's going to take 72 hours. Let me favorite this thing. So then that gets the process started, right? So prior to that, the thing that makes them maybe click the favorite is seeing the sample data first. So that's one way to mitigate this time factor, right? And one thing I wanted to note too is in doing it, it's very important that you tell the user it's sampled. And you need to, because if they're like me, it's like statistics are kind of in one ear out the other. I kind of remember confidence intervals. You need to explain what sampled means in terms that your user will understand. You'll know best if your user will understand what confidence is. In our case, media planners don't really know what that means, so we need to try and explain what that is. One example I just brought up is, because we're looking for flights back to the East Coast to visit the in-laws, is Bing Travel. And they do a pretty cool thing here where they say, hey, you should buy now because it's going to be going up soon. And we have an 80% confidence in this. So this is one example of taking like a sample data set and kind of coloring the context that the user has in reading it. So you can make decisions based off the sample, but just know that it's not the full data set. We're not responsible for what's going to happen, right? That's super important because that builds confidence for the user in your system. You're not, pulling a fast one on them. It shows that you're being honest with what the data is. So again, it takes 72 hours. Another solution, and this is getting a little technical, implement a GUID and a system cache. A GUID, if you're not familiar, is just a global unique identifier. So what we're doing when we run an ADR is, and we look at this, people often run the same ADR. Like the audiences aren't that creative. Like they could be saying, I just want to see what gender women correlates with. And it's very often the case that someone else at some point in the system today has run that report. So if the sampled report itself takes 45 seconds to 2 minutes to generate. So even the sampled report's slow. So with a GUID, what you can do is say, hey, these results, tag this query, say we have these results, they're hot in the cache. If someone pulls this report, just serve them the cache report object. So it's almost zero latency, right? It's as fast as you can then get the data to the browser for them instead of having to go hit up whatever other processes that you're hitting up to get the data. So that's another way that we've solved this is the GUID. Where this falls apart, of course, is first-party data. So if, for whatever reason, the audience definition varies, the GUID is just going to fall apart. But if you have a situation where it's shared data, like third-party data is available to everybody, a GUID is a really good option. Okay. This is the next bullet point down, right? So we just talked about time with the ADR and the APR. Now it's cost, right? So when you have your business analyst coming to you and saying, as a UX person, you're like, hey, it'd be really cool if we had these results, this fast, so they can take action on them. They say, okay, well, that's going to cost us an extra $100,000 a month in processing costs. That's not going to happen. You're not going to win that battle as a UX professional with the people that are, dealing with the money. So one way to mitigate this cost, and it may sound counterintuitive, but it's make fetching data a non-trivial but enjoyable experience. And so the metaphor I like to use here is a speed bump. So if this query is going to cost your company $1,000 to run, you want to make damn sure that when they hit go, they want that data that they're asking for, right? The ways that you can do this is a summary statement. At the bottom, when they're composing their query, they're about to get their data, give them a preview, give them a best estimate of what this data is going to be prior to them asking for it. So, it's just human nature. Like today, I got my rent-a-car at LAX, and I'm driving, I hit no fewer than 6 speed bumps. If you think about why they do that, it's because you get in the machine, it's a new machine. If it's a wide open road, it was safe, I want to see what it can do, right? It's just human nature. So that's why we invented speed bumps for traffic. It's not a bad thing to think about with your UI. And you want to do this in a way that's not obtrusive. So obviously an alert box saying, are you really sure you want to run this query? It's going to cost us a lot of money. That sucks. So avoid that. But if you have something like a summary statement, it gives not only nice confirmatory information saying, hey, this is what you're going to run, but it slows them down. It makes them stop and think. Think about every terms of service agreement you've ever looked at. There's always a checkbox. I acknowledge that I read these terms of service. never read it, but you do it anyways. Just that action slows people down. So if you can just make them think for a second before they do this, it's going to help with your costs. So costs will have to run. Be sure to provide high information ROI in the product. This sounds like a no-brainer. It's like, obviously, we want to be giving them something that is a good return on investment for them, especially if they're paying customers for something, right? But what I'm saying here is it's more of a call to action to understand the deep questions, and even like what we've done with BlueKai is we've kind of atomized our UI, so the report serves a very small subset of questions. We answer those very well, and we allow them to take action. So thinking about the questions that your users are trying to answer, the problems that they're trying to solve, and providing that as quick as possible in the output is going to save them running more queries. So like we usually think of it in terms of like user-centered design, this good user experience. We want to try and design something that is doing this anyways, but think about it in terms of cost. When say every time they hit the stupid go button, it's $1,000, right? And that's coming down on you because you have ultimate control over this, right? You're the person that is putting the button where it is. So if you think about that, in that context, it really changes a little bit how you answer the user's question. Okay, so next problem. So that was cost, right? The third one I'm talking about is horsepower. So we've got the data, but the browser takes 2 minutes to render it, right? So I was just doing a test before this, just seeing like tabular data on my machine, which is, it's not the best machine. It's no slouch, right? Doing a test of, I think it was 200,000 rows, tabular data. I mean, that's kind of crazy to be doing a browser. It took 2.5 minutes to render. So you got to be thinking about ways to mitigate if your user, for whatever reason, needs those rows, right? So we got to think about other ways to get them the same data, answer the same questions, but just things that need brute power. So you're trying to draw a scatter plot, and there's 20,000 dots on the scatter plot. Like, asking that of Internet Explorer 8 is a big ask, right? So we need to figure out how to do things that are going to allow browsers to show the data. And one with tabular data that we've used very successfully is what I like to call soft pagination, because people are so biased against infinite scroll. But the idea of appending results as you're scrolling down, right? So pagination typically works. You have, say, 100 rows, move on to the next, move on to the next, and each time you're seeing 100 rows. With infinite scroll, you're able to do one very important thing that pagination doesn't allow for. It's compare row number 100 with row number 101, right? Because it's appending the data. So it's a way to get at this feeling for the user, like the user experience is, holy crap, I have 200,000 rows. I mean, that's good and bad, depending on the context. But it doesn't take that long, right? So they still have this data immediacy, like the experience of, my data's right there. And that's a very tangible thing when you start talking about people's own data, is that there's data immediacy. It seems like I could scroll and see everything I'd ever want to see about my data. So that's one solution. Another that we've implemented is strategic cache. So this isn't so much an issue with the ADR, but the APR, the audience profile report. So say they ran the report, it wasn't GUIDed, it took 2 minutes to get, right? And now they're like, ah, crap, I wanted to actually compare, because what the profile does is takes groups of categories, verticals. So like demographic gender, you saw demographic age in the slide I showed, and compares that audience with those verticals. So say they forgot one vertical. That would suck. That'd be a costly mistake if it took 2 minutes to add that single vertical. That's brutal, right? That's not fun user experience. So one thing you can do is, when you're calling that report, you can show what you know, right? Strategic cache. So we know of the 12 verticals requested, we know 11 of them. We can show 11, and we can show a contextual spinny on number 12 that we're fetching that data for you. And this is something that seems like duh, because we see it all over the place, but it's like, from an implementation perspective, it's actually kind of difficult, but it really helps the user experience. So those are just some things. Like I said, I wanted to keep it very conceptual. The Q&A, if you have technical questions, I can answer those as well, because I'm half designer, half engineer. But yeah, we talked about time, right? Cost, and straight up horsepower are the three things conceptually you need to be thinking about with big data, among others. But that's it.